Good morning, everybody. I am M.Ramamoorthy, Assistant Professor, Department of Computer Science and Engineering, Bharat Institute of Higher Education and Research, Chennai. Now I am taking the subject Parallel and Distributed Computing. So subject code U18Pecs035. So first I taking the topic in that introduction in the simulation and why we need the simulation and why parallel and distributed simulation model. Next one, the simulation and modeling is an introduction and motivation. So what is a simulation? The simulation is a systems that is represent the emulates the behavior of these another systems over the time. So in this case, this system, the computer simulation is a one where the systems doing emulate in the computer programming. This emulators in a sense is a triggering. So in this case of to represent the program, so whatever this collection of emulators is known as simulation. As in this case, this simulator and emulator. So this a small part of simulator is known as emulator. So in this case, some difference between the two definitions may vary. This emulator is a special type of simulator. Emulator is a computer devices or programs. Okay, so is a collection of programs known as simulation. It's like a collection of software. The sometimes definition is a fuzzy. When the something changes from this being, the simulations become a emulation. So duplicate functions on the systems using the different systems. Some of the virtual machines should be in that 86 emulators will be there nowadays. And also a simulator is a something as who is a behavior can be a place in the different for the better OS. Historically is a emulators means is hardware. Simulator means a simulator via the software. So in this case, okay, this emulator means is a hardware and simulator means is a simulation via the software. So this case, this simulator is a collection of emulator. This is a one part of simulator. It is known as emulator. Another one, this computer simulation is a computer programming that used computation to construct the representation of the behavior and model the particular of the systems over the time. This is known as computer simulation. This computer simulation is built on a purely mathematical models in the science and technology in the entertainment, and also using the so many applications in nowadays. And also, so why do you as a simulation? This software prototype is a prototype, it's one of the model and forecasting and planning, a training and education analysis process that have this different time of spans as day and year are like, okay, so whatever. So many things to be there in that simulation is a one type of model as either creating the prototype, either forecasting and planning and training and education and analysis process, whatever the analysis in this like using the simulation, using the software simulation. Okay, so next one, why the simulation? So observing an operational systems may be as a too expensive. So why we need simulation now? As while we are designing this computer chip that may be too expensive. So that time we are to first you apply the simulation, then we going for real one. That time using for simulation and also dangerous as using this forest fire and chemical as well is so dangerous. So that time, yes, what they are doing in the real time as before itself, we are to apply some more examples, some more tests that be done in that. So that time, that type of various application we are using the simulation. And also time consuming as weather. As weather forecasting is nowadays very important one. So that weather forecasting also is what are there in that past result that based on this fast result or based on this fast forecastings that will be analyzed in the future. So that time using that simulation model. And also it's not possible in case example creating as a universe that is also is not possible. So that is a simulation that is also is possible are morally and ethical unacceptable in this case of spread and diseases. Spreading the diseases that is also is too possible to doing that simulation. and also part of the systems may be not observable. In this case of internal and silicon chip and biological systems, these all those things to be are not view in this wherever in the process in that. So in this case, we are using the simulation is possible to as what they are inside, that is to assumption that simulation should be done in that. Okay, and also so using some more simulation to analyzing this systems before that build, to reducing the number of the design the mistakes. In this case, if you're doing this high cost design in this particular systems, in this case of high class server, this high cost server, in this case high configuration server, so that time we are using this some simulation and the design, so that will be helpful to reducing the cost of reducing the mistakes also, and also optimize design. That is also possible wherever in the simulation to applying that, and as a replacement of purely mathematical representation to explore the physical system, so that is also is possible. And also is like analyzing the operational systems and creating the virtual environment for the training and environment, that is also is possible here, is where applying this simulation. And also a case of the simulation. So in this case, the system analysis. So in the application area, the system analysis is one of the role, and as online simulation, that is also is very helpful in that. And a virtual environment, so virtual reality, virtual things, whatever nowadays we are having this so many applications of virtual reality, that is we are like as a real, we are think as a real. So it's like an entertainment side, otherwise application side. In this case of automobile industries, like okay. So and also application system analysis, where their application analysis in the simulation. This classical application, so many simulation should be to helpful in that. This focus on discrete event should be helpful in the simulation. First one application is telecommunication networks and transportation systems, and nowadays we are in this electronic system like a computer design and logic circuit designs wherever in that. And also battlefield simulations, blue army and red army, like as a gaming like and also ecological systems and manufacturing systems, logistic systems. These focus on typically on this planning and design systems to be very helpful in this nowadays real-time applications. And also application system analysis, this is the basic things like classical applications in this simulation analysis, the design optimization systems, weather forecasting and climate change analysis, and astrotherapies, therapeutic applications, and aerospace application, and automatic design application, and telecommunication network, and transportation system, and microelectronic systems application, and computer systems, and battlefield simulations, the some more automation industries, and ecological systems. Then how to ecological systems to be work in that, that is also possible to do the simulation. And manufacturing systems and logistic systems, this focus on typically is not limited, as apart from these so many applications will be are used in that simulation. And also focus on typically as the plan and system designs, that is also helpful. As the example is first we going for the taking the telecommunication networks, the evaluate the networking hardwares, so that is to working is real or not, like that. And also software and protocol services and new technologies for the networking, such as image and data video addition to these voice ports, like that. Okay, these are the telecommunication network area we are using, like a data transferring or data transferring rate, and each and everything should be are analyzing, even though as a client and server data analysis model, how will be our topic is there, if it is topic is there or not, like that. Each and everything should be are analyzed to via the simulation. And also as a parameters like a fiber optics cable and copper switches and everything, these hardware devices also should be analyzing via the simulation. And metrics as cell losses and parallel simulation, that is also possible. And transportation systems, micro simulation, transportation systems to analyzing the macro simulation and micro simulation. Macro simulation means top down approaches, micro simulation means bottom up approaches. So in this case, the top down approaches, the focus on the observable behavior of the systems. In this regenerating this observable behavior in the terms of aggregated the coarse and coarse grain and short run time. So that is also is possible in this micro simulation and macro simulation. A micro simulation means bottom up approaches with the detailed of this behavior of the individual entities like a cars and uh, vehicles, and each and everything should be are following the behavior that should be are analyzing, should be our micro simulation that will be possible. This is a design is known as a fine grained. Previously a macro simulation is a coarse grain. This is the bottom up approach is known as fine grain. This finely tuned to can to find out the things exactly like what they are vehicle, how they are going like that. This all those transportation system application will be are helpful, and also is automatic things, and also is air traffic controller and evaluating adding a new runway allow this congestions in this case of to traffic to reducing the traffic via the analysis in this flight aviation departments, and also is like a air force oriented applications. And also application the system analysis, computer system and logic circuit design, that is very helpful as VHDL, very high definition language hardware description languages. VHDL, very high definition language, VHDL hardware description language, that will be our VHDL. This is a gate level logic simulation that is focused on modeling an individual circuit is implementing this Boolean functions and storage elements. That will be helpful in that computer designs and circuit designs simulation. And also high level models, switches and processors and memories. And those are these apart from that, so many things should be there in that wherever in the computer design and circuit design. And this battlefield simulation is virtual environment and immersive in the loop and hardware in the loop, and evaluate this effectives and new devices, and software in this loop and human in the loop. Each and everything should be, it is not a limit, and you are, even though it's a geographical distributed training environment, that is also is very helpful in that real-time application in this simulation. And also the ecological systems, that is very helpful. Macro and micro level simulation, even though is insect analysis, ant and bees and log tests. So in this case of need to scalable and simulator and everything. And also so evaluationary Lamy diseases. So nowadays we having these plant and having this, so many diseases will be there, even those human and the plants. So that will be a disease analysis. We are helpful in that simulation, the simulation models. And also manufacturing industries nowadays having these so many manufacturing industries like automations, like a vehicle manufacturing, car manufacturing, and a two-wheeler manufacturing and everything. These now simulations can be added to design analysis, and this aid for the factory layouts and equipment decision on operation policies and everything. So in this case you see in the diagram, so in the seeing the diagram in this case, so you can follow the everything. So the scheduling tools and production process and everything. So in this case of anything wherever the production is going on, so as the employer will be doing the product. So as a design the product and doing these machineries and everything. So in this case of anything to be fault to be occur in a particular product, that should be to find out the simulation. The simulations model will be helpful to used to find out and everything. This is why that to applying the simulation, and you train the employees to based on the design in this to applying the simulation. And also part of the real time and the online controller systems are many commercial simulation tools were helpful, like in this case of even though nowadays we are in this construction field and agriculture field and education field, so many, it is not a limit. Simulation is very helpful as nowadays actually. So before that even though if you are train the employee, the simulation very helpful. So why? Because the training is, each and every training process should be to maintaining on according to that simulation only. And also application like in this case a live database feeds will be there. This flight, each and every two more flights will be are coming in at a time. This situations database will be how to handle to train the systems as based on the decision making also is available. So in this case, this situation database will be there, and this live database data feeds will be there. The live data feeds should be to helpful as based on this feature, and production should be to maintaining the database. This database should be forecasting tools should be helpful is fast simulation. The simulations should be to interacting the simulation environment. The interacting environment should be decision makers will be helpful to making the decision in effective via the simulation analysis. In this case, this flight and movements and fast database and future database as a predicting of in the future. The decision making is very decision makers to very helpful to the making the decision very fast. The simulation very helpful. This simulation tools are using fast analysis and alternate the courses for the actions in the time critical situations. Initial stages initial stages to simulation from the situation in the database, and the faster than the real-time executions, and evaluating the effect decisions, and also air traffic controller, bottle management, and the simulation result may be or need to only as the second one. Another one, this application of the systems in this case, virtual environment. This training and military medicines and emergency and planning and entertainment and social interaction. These all those things to be are helpful in this simulation. Even those military application is like a real vehicle or so to train the military peoples. So example like a training period. So and also medicine to giving the medicines to so based on the reaction to be increased or decreased of this dosage or like that. And also the emergency as emergency field like as fire and earthquake like that. That is also is possible to making the simulation. And planning as planning lessons in this case the construction planning and everything. This is a building construction. This designer building designer should be to maintaining and the simulation whether how will be affected to calculate calculating the cost and timing and everything. So that is also possible to make the simulation. And entertainment in this case of like a movies, real movie and animation movie and games are like that. That is also possible. And social interaction, these online games, that is also possible. Online games like to via the network. The simulation are often used a virtual environment to creating the dynamic generating entities, and also advertise helpers to the video games, and defense the computer generating the force CGF, and also automated forces, semi-automated forces. Automated forces, you know that actually is like to applying for these army automation vehicle should be to design in the designer. That is a simulation should be before itself we are make to train the army force peoples. And also physical phenomena, it's like statutory projectly and building blow off and environmental effect in the environment. So what they are rain washing and out trainers, these all those things to be to apply in the simulation like. Okay, so under virtual environment and analysis. So what are the virtual environment things to be there? First one is a typically is a characteristics, and is x-axis is a analysis, and y-axis is a typically characteristics. As x-axis is analysis and virtual environment. The typically is objectives, quantitative analysis of the complex systems, and virtual environment create the recent entertainments in the representation, and execution of pacing as fast as possible as a virtual environment. This is for real time, and is human interaction to including this often extended observe, and virtual environment is integrated to the control the entities, and accuracy, you know, statistical correct results. This human prospecting display and the large role. These are virtual environment. The real time now we can statistical analysis the correct results. And also is what are the model simulation model. So it's a shipping construction model. So you see the diagram here. These are shipping construction. This is based on this shipping construction as a designer as possible to as before itself you are trained the design. Okay, and also is a here is a second diagram. This is a construction as a building. Is a each and every step by step process of the construction. So that is also is to possible to make the simulation. And also flight designer is a flight designer. So that is also is possible to make the design in an effective way. And also nowadays we are having this as a passion design is one of the advertisement, and also space and design is one of the things to be there in life nowadays. So that is also is possible to is based on the time and even based things to be are considered in this simulation. And also the neurons cells, and these are the analysis based application should be are helpful in the simulation, like a genetic and a neuro based analysis and genetic based things, and cell based design, that should be make very helpful in that application of simulation. And also model and systems definitions. The first one is the system model, the systems under the investigation, SUI, the system under the investigation or physical systems. System are either are going to this investigation, that's very helpful in the simulation, as in that are we are using the real time the physical systems. In the real or imaginary systems that should be are mentioned in the model. As the first one is a model is a representation or abstract of this SUI. SUI means a system under the investigation, SUI. And as description of this observed the behavior, this simplified by this uh, ignoring this criteria in these details. So here is we are interested is a model as the dynamic systems, or the systems to be exhibit the behavior over the time. And also what is my dynamic of this model? In this model we are having the collection of interacting of the so many entities, like so many procedures will be there. So the step by step process and application of on the virtual environment, use of the training, like a military application, emergency and medicine and planning and entertainment. So these are the area will be applied in that real-time application using for simulation. The simulation are often used a virtual environment to creating the dynamic computer generated of entities. Like nowadays we having this automated and semi-automated like things, and physical phenomenon you are building and blow off and down up like that. So environmental effect and that should be analyzed in that in the real-time application. And also is like a uh, tested and evaluation. The simulation widely used in interaction with the physical component. Example, as tested and evaluation behavior, this is sometimes called as a emulation. Okay, this electronic circuits, that is also we before designing of electronic circuit or electronic board, that time we need to follow the some more simulation. So why? Because we need to 100% of effectively design. And also is the communication networks, that is also is very helpful in the simulation and the defense applications. And a historical overview. So in this case of 1940 is a computer simulation is a Makanta project of model of nuclear denunciation. So that is a 1940s that simulation only are this first simulation. And also 1950 is a analog to computer commercial available to use in continuous simulation, is solving this different equation and problems in 1950s. And 1960 is a digital computer offered as alternative to the analog computer to provide this means of simulating and discrete event systems. This corresponding as stochastic phenomena. So in this in the year of 1960, this is for this first object-oriented programming language. This simulation model will be coming in the 1960. And 1970 and 80 is a numerous of models and simulation application are developed in the area of simulation in this computer based. And also is 1980s is on 90 in mid-date of 1990s is the emergency or the parallel and distributed simulation simnet will be coming in the simulator standard of computer phenomena, computer things. And also after that behind of 1960 as complex systems and networks should be are coming. So that is also possible to done in that year of after 1980 in this so many simulation things. And also it's like a computer simulation is a computer programs that models a behavior of the physical system in the real time. That is known as a simulation. And also a programmable variable, a state variable represent in the current state of the physical systems. So even though the state in essence as a position of the event, in this case is a processor, is a collection of events and action should be there in the particular process. So even though is the program variable, even though these each and every event should be make the status, make the state. Okay, so each and every event should be a make the state. So the state should be a consider in that analyze based on this if this process is completed or not, like that. And also simulation programs to modify the state variable to model of the evaluation of the physical system over the time. Simulation taxonomy, this real-time mechanism and simulated mechanism. So in this case of a real mechanism means live, the simulated mechanism means virtual. So in this case, if we can compare in that, so simulator, the simulator is not a real one. The simulator is only for is not a physical, is like only for system oriented to analyze purpose only you are using that simulation mechanism. But real time is not like that. Real time is a real time mechanism, is physically a hardware and in the loop should be there. But the simulation mechanism is a constructed oriented, as user, a developer can design and user can be if you are there in the friendly, that time you are using that user. Real peoples in that real mechanism, and simulated mechanism is a virtual. This simulated people's hardware in the loop, and the simulated mechanism are constructed. This type of simulation live, real people operating the real equipment, this is known as live. A virtual means real people operating the simulated equipments, like a simulated devices, simulated softwares. Okay, so example like a flight simulator or a network simulator or like that. A real-time example, some more things to be there in that. Even though it's like a argument reality and virtual reality things to be there in like a real-time entertainment. Okay, and also it's like a major application area analysis, war gaming and logistics. So real time application, major application area na. So transportation and construction and design, war gaming and logistics, even though it's like a training na, training areas na, platform level and command level. This platform level now low level, so that should be like a students training, and command level now teachers level are like a designer level training, and test and evaluation hardware in the loop. So this is very helpful in the simulation in this major application area. And also discrete time. So what is my discrete time and continuous time? You know that actually is a discrete in a sense. So is a time gap will be there, even though equal interval of the time is sampling. You know that actually sampling already you have studied, no? Electronic devices and electronics basics things. So the sampling is a process, is an analog signal into digital signal. So when they are converted into analog signal and digital signal, so that time very helpful discrete time signal, very discrete time things to be are helpful. So is a discrete time essence is a slices of the equal interval of the time in the sine wave signal. So it's a continuous time signal. You know that actually continuous in essence, you know, is a sine wave. It's like in this case of like a sine wave. Discrete time, a state of the system should be viewed in this changing the points and the stage based on that time. And the event associated with each state transaction will be helpful, and each event as the timestamp will be there. So why? Because each and every interval of the time should be there in that discrete time period. And also continuous time. Next one is a continuous. The state of the systems is viewed as changing this continuous across the time as based on the event. This continuous means events. Discrete means is only for the based on the time. These systems are typically described by the set of differential equations. So in this case of continuous time signal, the distinction is a conceptual. In this practice, a continuous simulation and a discrete time axis will be there, even though it's a x-axis, y-axis model. And as a discrete event simulation, the state changes can be occurred in a irregular points of the time, and also in the practice on the can always a discrete scale as mapping a discrete event simulation and time step model will be there. Even though it's a deeper level and the time discreting should be continuously in the next slide. And also simulation taxonomy as so many things to be there. Computer simulation, a discrete model and continuous model will be there. Under the continuous model, we not taking here. And also discrete model, we are even though it's a digital, wherever in the simulation as a digital is an important one. As a event driven model and time stepped model. Event means as a based on the event. Time step means as a based on this as time gap interval should be there. This continuous time simulation, the state the changes occur the continuously occur across the time. Typically is a behavior and described by the differential equation should be taken care. And also it's a discrete time simulation. The state the changes only occur the discrete time instance. So where the time should be mentioned, the schedule should be mentioned here. So that time this event, the particular event should be or make it, and the particular event should be done. There's a time step as a time advanced by the fixed of time increment model will be there. In fixing the schedule based on the schedule, they can processor should be taking care of the event. And also the event step now a time advanced occur with a regular incremental model should be there. Time step model and then event driven model. This time step model is a state variation will be there, and this y-axis and x-axis simulation time will be there. This is not time step execution. This is based on this time period. X-axis is a maintaining of T1, T2, T3 like that. As a time based event is based on this time period. This is the event should be performed and execute an event driven execution. Each and every process as after the event is completion, this automatically time should be set or not. That is the based on the event driven execution based on the user purpose. This parallel distributed simulation, this first one is an introduction and motivation. This parallel and distributed model. So nowadays we have this why we need in this parallel. As the same time we can perform these many things. At the same time we can perform. In this case, example, you can cut the one apple in these 10 slices. Is possible? Yes, possible. So within these 10 slices, so to eat in this different persons very easy way within a fraction of second. But is one apple, if you eat in this within a fraction of second is not possible to eat. So that is a difference. This parallel and distributed process will be there. In this case of distributed process, same like that. So this apple, that is 10 slices should be cut in the different peoples. They within a fraction of second to eat in the apple. So parallel system is not like that. This parallel system is a tightly coupled system. The distributed system is not like that. It's no loosely coupled systems. Securities will be less, but parallel is not like that. Next, we going for this parallel and distributed simulation model introduction. This parallel and distributed model simulation is the first we going for this parallel. As parallel simulation is referred to as a technology concerned with just executing the communication and simulation over the computing systems and parallel computing processor. This is known as a tightly and multi-processor system. What is my multi-processor? So nowadays we are having this like a exa arc core like that. Okay, this core processing will be there. So within the chip is n number of processor will be there. Okay, so in this case, so within the systems is like a within the chalk piece having this n number of particles will be there. So similarly, this within the chip where we are designing this designer in this architecture designing this particular systems. So there will be to fixing this n number of processor should be to connecting interconnection manner. So that processor will be sharing that common memory. This known as is a tightly coupled processor in that parallel. So in this case, to reducing this burden of the processor, So to easy to increasing the speed of the systems and also is a n number of processors should be done in at a time. So this is known as a tightly coupled processor. This workstation to interconnection via the network example in the internet. So within this connectivity that are also possible, and also handle these computers via the wireless links also is possible in this parallel computing. And parallel computing, this is a tightly coupled processor and a shared memory processor and distributed memory distributed memory multi-computer. That is also is in this parallel. This is no tightly coupled processor. In this case example, you've seen that shared memory and distributed memory. So shared memory in essence, as memory will be shared in that common memory. This memory will be shared in each and every CPU processor. So here no, so here we are distributed and this parallel processor. This parallel processor share in that memory in that common multiprocessor. Multiprocessor, a number of processor will be shared in that common memory. And also distributed computer, so loosely coupled processor, this network workstation will be there. And also sir, a parallel computer and distributed computer is a physically extended machine room and building city and global. This one is distributed. This processor na homogeneous, this is no distributed, no heterogeneous. This communication network where custom switches will be there, then commercial LAN and WAN should be distributed. And also is a common latency is a few 10 of the microseconds. This is no hundreds of the microseconds of the system. So why? Because so network will be connecting is each and every system. So that's why we are there in that. And also shared memory multiprocessor as is CPU. Many examples: Sun, Dell, SGI, and etc. So many nowadays we have so many companies will be there. The CPU is a number of CPU will be connecting within the network interconnection network. This memory will be a connecting input output devices will be connecting. This programming model share variable and synchronizing via the lock. In this case of a locking process will be there, processor 1 and processor 2, as a number of processors should be there. And those distributed memory mechanism, this example IBM, as IBM is an important role to perform in that distributed mechanism. The CPU, this a number of CPU and caches of memory will be there, and the individual memory should be individual memory will be there, individual systems. That individual system should be communicated in that interconnection network. This is known as a shared interconnection network things. And also, so why executing over the multiple CPU? So reducing that model execution time, reducing the time, actually reducing the latency and increasing the speed of the systems and increasing the throughput of the systems. Okay, that's why. And may not having this enough the memory, this single CPU will be taking care. And also a scalable performance, maintaining the same execution speed and a bigger model and virtual environment by using this more CPUs and particularly is important in the virtual environment. And also geographical distributed users and resource of the database. This example is a database and specialized equipment will be there. And also integrated simulation running the different platform and network rather than the port. And this fault tolerance is not easy in that made in this multiple CPU. As a multiple CPU in a sense, as a number of CPU will be connecting in this interconnection network. Historical of this perspective, as the first one is a 1975. As before that, as 1975, as after 1975 is having these Candy Bennett algorithms. So this is now 90 before mid date of 1975 and 1980. The mid date will be coming this uh, design, and also 1980 simulation design, and also 1980 and 1985 this simulate will be coming, simulate will be coming, that known as simulator and networking is known as this coming year 1983 to 1990. And also mid time is a time wrap algorithm will be coming. And as after that, as a 1990 and 1995 optimization synchronization things to be optimized, optimistic synchronization will be coming. That time is a 19 to 95. This high level architecture is coming nowadays we are having that. and also is like a HAL evaluated eye level things, eye level architecture things to be there. So that is evaluated 1910, sorry, 2010. Today's we are that. Then defense community in this distributed interactive simulation DIS and aggregating level simulation protocol ALSP, that is coming on 1990 and 1997. In that internet gaming and communities, massive multiplayer online games should be there nowadays. So that is also as one type of simulation that processor will be able to make it fast on that online games. Another one, the summary, the simulation should be seeing this wide wrapping of using these systems. So design and the management of the decisions to adding these systems making the fast. And also it's a fundamental concept of the state changing the state across the simulation time, the continuous versus discrete time simulations. Here is focus on this discrete event as based on the simulation, and also the reason for the distributed and execution simulation over the multiple computer including this first one is a performance and geographical distribution and easier interaction of the systems. So that's why you are using that simulation. And parallel distributed simulation technologies developed large independently at different R&D communities, like a high level performance computing and defense and internet and gamings. So these are the things to be there. Any queries? And also we are make it on that a simulation. So each and everything should be there. They sharing multiprocessor, distributed multiprocessor, and parallel and distributed computing. This all those things to be there. So under these simulation topics, we are the so many things. Uh, Application and virtual environment and models, so many models like shipping and constructions and flight designs and fashion designs. And also is nowadays we are having that neuros cells movements and fuzzy movements, fuzzy things, and neurological analysis simulations that should be there. That is also possible in that nowadays application, real-time applications. So whereas mainly we are focused on this simulation, is apart from that so many applications nowadays we are helpful in that research and development, and also it's like a simulation uh, computer, even though it's computer designs like hexacore and octa-core designs like IBM and HP systems designs. So many designs should be possible in that real-time environment. Thank you.